And we're going to be looking at an example of an indifference curve for imperfect substitutes. I'm going to talk you through one of the figures in the book. Okay. So we're going to be looking at two goods so that we're able to draw. We have like so. So let's have potato chips on the vertical axis. So number of, think of small bags or whatever, and soda, soft drink on the horizontal axis. Okay, so think of, small cans of this. Okay, so you're getting ready for an evening of binge watching or whatever, and you want to have, or, presumably there are different combinations of chips and soda that are available to you. I want to see how we can rank these different. Okay, so first, just as a benchmark, think of the case where there's, if these two goods were perfect substitutes, from previously that, perfect substitutes have straight lines, where indifference curves are straight lines. So, this would be the case. And if, indifference curve if, the two goods are perfect substitutes. Okay, so no matter how much potato chips you have, you're always willing to trade it off for the same amount of soda. Okay, or the marginal rate of substitution, if we want to use a fancy word, is constant. Okay, so we could say, well, think of 4 potato chips, 4 bags of potato chips. I'll zero off down here, of course. That would be on the same indifference curve as a bundle that has 2 bags of potato chips and 2 cans of soda, and that would be on the same indifference curve, for instance, then as a bundle that has 0 potato chips and 4 cans of soda. Okay. So that's sort of as a benchmark. We want to, compare to that when we're looking at imperfect substitutes. So let's deal with imperfect substitutes. Well, that's saying that how you're willing to trade off one good against the other and still be equally well off depends on how much you have of each of the goods. Depends on your position. Okay, so your marginal valuation of the different goods, your marginal utilities, will depend on how much you have of the goods. So of course this will vary across individuals. You could be equally happy with 4 bags and potato chips and no drinks as with 2 bags and 2 drinks. But for many of us, we would think, if we're only consuming potato chips, it's kind of dry, right? It'd be nice to have something to water the mouth with a bit. Okay, so an indifference curve would look something like this. Early on, you'd be, if you starting from a position with lots of potato chips, very little to drink, you'd be willing to trade off quite a bit of those potato chips to get some more to drink. Or another saying, the slope of the indifference curve, the marginal rate of substitution, is high here. Okay, so steep. You're willing to trade off a lot of potato chips to get just some more soda. And then, the less potato chips that you have and the more soda that you get, the less is that going to be true. Okay, so, in a position like down here, have lots of drinks, certainly not thirsty anymore, but nice to have a little more crunch, right? So in a case like this, you're, willing to give up much less in terms of potato chips to get more soda. Okay, so what is this saying? Well, it's saying that the marginal rate of substitution depends on how much you have of each good. Okay, so when they have this kind of pattern, they will then be, bowed towards the origin like this, or we could more fancy way, say that they're strictly convex, right? If we're tying a string between 2 points on this on the indifference curve, that string will always be above the indifference curve. Okay. Another point to note here is that we're making do with less of if we're thinking of just the or the perfect substitutes case. Here we would have 2 of each. With when preferences are such that goods are imperfect substitutes, I'm willing to have fewer units in total if I have a nice combination. Okay, so this is like, going back to Aristotle, nothing in excess. Just want to have, a nice combination. Okay, so this is the case of imperfect substitutes, and we often use that kind of example in textbooks and in economics. We think it's a fairly common situation, but clearly doesn't hold for everything. Okay.